Going to be a short video that's going to have a very short homework assignment after it. This video is required, and you have to make sure that you do this before you start the next section. So the goal of this video is to talk about the difference between rational and irrational numbers. And as an example, I want to talk about some of the characteristics of Mr. Schmidt and then some of the characteristics of Mr. Schmidt's 8th graders to help us with the definitions between rational and irrational numbers. So one of the things that's true about Mr. Schmidt is he's very easy to work with. He's not frustrating or difficult, things like that. He's easy to understand, okay? The way he says stuff is very clear. It's not complicated. And then, of course, he doesn't talk forever. So he's very good at making sure that he stops talking after a small amount of time. Now, for contrast, Mr. Schmidt's 8th graders, okay, they are sometimes very hard to work with. Occasionally, they're very hard to understand, depending on the topic. And then, of course, the most important one is sometimes they go on and on and on, over and over. So I want you to think of Mr. Schmidt as a rational number, because Mr. Schmidt has a lot of the characteristics that rational numbers have, and he's also a very rational person. By contrast, Mr. Schmidt's 8th graders frequently are very irrational, and they have some of the same characteristics that irrational numbers have. So let's get into a little bit more of the math examples. And if you're curious, yes, I'm joking. This is just a funny way to try to remember some of these characteristics, which are, so if we're dealing with rational numbers, these numbers are usually fractions, decimals that end or repeat, integers, which are positive and negative whole numbers, and then percentages, because percentages we know are just fractions or decimals. Irrational numbers, by contrast, are decimals that do not end and do not repeat. And so it's key here to make sure that they have to do both of these. That if you have a number that it ends or it repeats, then that would make it a rational number. So it has to end or repeat. So it's not either or, it's kind of both. And anything that can be written as a fraction with whole number, numerator, and denominator. And that's going to be the really important part. So let's get into some specific examples here. So an actual definition of a rational number is any number that can be written as a fraction with a whole number, numerator, and denominator. So that would be something like 1/2 could be a rational number. You also could have something like negative, pen's not working here, negative 2/3 would be a rational number. There we go. Negative 2/3 could be a rational number. You could also have really crazy numbers like 1,243 divided by 65. That would make a rational number. Now, if we're talking about decimals, these decimals have to end or they have to repeat. So if we're doing a number like 6 2/2, that would be a rational number. You also could have a number that is really long, but as long as it actually stops, that would make it a rational number as well. And then finally, if you have a number that goes on forever, but it repeats, and there isn't a good repeating sign here, but if it actually repeats, that would make it a rational number. And the reason for that is because decimals that end or repeat can be written as a fraction with a whole number, numerator, and denominator. It's possible. It's hard, but it's definitely possible. And now any integer or any percent are also going to be rational numbers. So that's something like -4, rational number. 23%, rational number. Oh, my Lord. There we go. Or even if we have something like -0.8%. Come on. There we go. My pen is really difficult today. 0.8%, that is also a rational number. So then the official definition of an irrational number are any number that cannot be written as a fraction or with a whole number, numerator, or denominator. So special numbers like pi, which is written like this, and then pi is written with that symbol, is an example of an irrational number because pi goes on forever and it does not end or repeat, which would make it irrational. Any decimal that actually doesn't end or repeat, so if I had, you know, this is going on, and it just keeps going, going, and going, and it never ends or repeats. That's supposed to be a 2, by the way. That would make this an irrational number. And the one that we're going to deal with the most, okay, and I want a big underline here, are non-perfect roots. So if I had a number like the root of 9, the root of 9 is actually equal to 3. That makes this a rational number. But if I had the root of 10, that is equal to about 3, but it is not exact. Therefore, it makes it an irrational number because a root that is not a perfect root cannot be written as any fraction. We could also do this for cubed roots. The cubed root of 27, there we go, is equal to 3. So that would make it a rational number. But if I had the cubed root of, let's say, 28, that is an irrational number. So any non-perfect root. So if I did the root of 65, that would be an irrational number. And if I did the fourth root of, let's say, 92, not a perfect root, does not have a whole number, therefore makes it an irrational number. So the assignment for this is I want you to create 5 examples and 5 non-examples of rational numbers. Write down the definitions to rational and irrational number in your own words. They cannot be an exact copy of my definitions, but they need to be something that you can easily understand. If you have any questions, please let me know.